You've probably seen these little six-wheeled robots rolling down the sidewalk, right? They're becoming a super common sight, little couriers on a mission. But have you ever stopped to wonder what's actually going on inside that little box? Like, what's it thinking? Well, let's pop the hood and find out. So let's take this little guy, the Amazon Scout, as our guide today. Its job sounds simple enough, doesn't it? Just get a package from point A to your front door at point B. But think about it. That short journey is basically a minefield of unpredictable stuff. And that's the real question, isn't it? What kind of AI magic is packed inside that allows it to deal with sidewalk cracks, curious dogs, and toys that kids just leave lying around? Let's break down exactly how it works. Okay, first things first. Before a robot can do anything, it has to be able to see. But here's the cool part. It doesn't just see the world like you and I do. Its perception of its surroundings is, well, it's way, way richer. This is where the robot's kind of superhuman senses come into play. It's not just using a camera, no way. It's using something called sensor fusion. So it's combining data from regular cameras for all the visual details, LiDAR, which uses lasers to build a super precise 3D map, and even radar, so it can see through stuff like rain or fog. The AI's job is to take all of that and weave it into one single perfect picture of the world. So with all this information pouring in every millisecond, how does it make sense of it all? Well, that's where the AI's visual cortex kicks in. It's a type of deep learning model called a convolutional neural network, or CNN for short. And boom, this is the result. The CNN doesn't see a random jumble of pixels like an old computer would. It sees objects. It takes that live camera feed, and in real time, it identifies and labels everything. That's a person, that's a box, that's a wall. It's turning total chaos into perfect order, giving the robot a clear, structured map of what's around it. Okay, so our robot can now see what's right in front of it. Awesome. But how does it know where it is? And more importantly, how does it figure out the best way to get to your door? Well, that is the next big piece of the puzzle. It uses this incredible process called SLAM. It stands for Simultaneous Localization and Mapping. Now, to get what that means, imagine walking into a pitch-black room you've never been in before. You'd probably put your hands out, right? You'd feel for the walls and furniture, building a mental map, while at the same time keeping track of where you are inside that map. That's exactly what the robot is doing with its sensors. You see, regular GPS can be pretty unreliable, especially between tall buildings or indoors. So the robot has to create its own personal navigation system, literally on the fly. SLM is what lets it constantly build and update its own map, figuring out the layout of the world and its own spot in it, all at the same time. So now it can see, and it has a map of where it is. The last piece of this navigation puzzle is called path planning. This is where the robot's brain gets to work solving this really complex problem, calculating the absolute best route. And not just the fastest, but also the safest and most energy-efficient one. You've definitely seen this before on your own navigation app. The AI plots this perfect path, like that digital blue line on a map that just elegantly weaves around all the stuff it needs to avoid. It has a plan, it's ready to go. But what happens when the real world throws a curveball? You know, what if a pedestrian suddenly steps out or a car just starts backing out of a driveway? A plan is only good if you can change it, right? Back in the day, you'd have to program a robot with this giant, clunky list of if-then rules. You know, if an object is 3 feet away, then stop. But you can't possibly write a rule for every single thing that could happen in the world. It's impossible. So modern robots use something way more flexible: reinforcement learning. And honestly, this is a total game changer. Instead of just following a rigid script, the robot actually learns from experience. It runs through millions of simulations and real-world tests to figure out which actions lead to good outcomes. It's basically teaching itself how to get around in our world. And here's the basic idea behind how that works. It's a really simple feedback loop. The robot, which we'll call the agent, tries an action out in the world. If that action gets it closer to its goals safely, it gets a reward, a little digital pat on the back. If it bumps into something, it gets a penalty. And over again, its AI learns to pick the actions that get it the most rewards. So let's put it all together. A person walks out in front of the robot. Step 1, the sensors see them instantly. Step 2, the AI predicts where that person is probably going to walk next. Step 3, it uses its short-term memory.
a tech called LSTM, to remember their recent movements. And finally, step 4, the AI planner recalculates a brand new safe path around them. All of that happens in a fraction of a second. It's incredible.
So, through this amazing symphony of seeing, mapping, and learning, our little robot makes it safely to the front door. The package is delivered, mission accomplished. But believe me, this is just the beginning of the story. So to recap, what we've seen is that this isn't just one magic trick. It's 4 key AI pillars all working together in perfect harmony. You've got object recognition to see, SLAM to map where it is, path planning to figure out the route, and that dynamic obstacle avoidance to react to anything new.
And get this same AI brain isn't just for sidewalk bots. It's the same core technology that lets robots zip around Amazon warehouses, that powers autonomous taxis through busy city streets, and even guides delivery drones through the sky. The basic ideas are universal.
But the really, truly exciting future isn't just about making one single robot a little bit smarter. It's about what happens when they start working together, thinking together, almost like a hive mind. This idea is called swarm intelligence. Instead of one central computer telling everyone what to do, the robots actually communicate and coordinate with each other to solve huge problems. Just imagine a whole team of drones spreading out over a forest to find a lost hiker, or a fleet of delivery bots that dynamically reroute themselves to cover an entire city as efficiently as possible. So, we just took a peek inside the mind of a single robot that has mastered the sidewalk. But if you scale that up to thousands or even millions of these intelligent agents all working together, what does that future look like? What kind of massive challenges could they solve? Now that is a future that's worth thinking about.